80,000 pounds, 6% grade. The driver hits the brakes and feels them go. They squeal. They smoke. The cab fills with the smell of cooked drum linings. And then comes the worst sound of all, which is no sound, because the brakes are finished. For most of the 20th century, that was how American truckers died. On Cajon Pass, on the long 6-mile descent out of the Eisenhower Tunnel. Then in 1961, the man whose name is stamped on half the diesel engines in North America, Clessie Cummins, patented a brake that solved it. It didn't use friction, it used the engine itself, turning 6 cylinders of pulling power into 6 cylinders of holding power. Within a decade, it was standard equipment on the heaviest rigs on the road, and in city after city across the United States, lawmakers banned it. Not because it failed, because suburban developers built houses next to the highway after the trucks were already there, and they didn't like the noise it made when it worked. Cajon Pass, Southern California, early 1930s. A man in his early 40s is hunched at the wheel of a heavy diesel-powered vehicle, descending the grade with the city of San Bernardino sliding into view through the windshield. His name is Clessie Cummins. He is the chief engineer and namesake of the Cummins Engine Company, and he is in the middle of one of the long cross-country demonstration runs he has been making for years, to prove to American industry that the diesel engine, a European oddity that runs on cheap fuel oil instead of gasoline, is the future of heavy transport. What he is not telling anyone, because he does not want to scare them, is that the brakes have been getting softer for the last 2 miles. By the time the grade steepens past San Bernardino, the pedal is dead under his foot. To understand why this moment matters, you have to understand who Clessie Cummins already was by the early 30s. He was not a hobbyist. He had founded the Cummins Engine Company in 1919 in Columbus, Indiana, with backing from a local banker named William G. Irwin. He had spent his 20s around the Indianapolis 500, where he learned that the difference between a fast car and a dead driver is usually the brakes. He had spent the next decade trying to convince American truckers, bus operators, and railroads that diesel power was worth the trouble of switching over to it. To prove it, he was now driving one across the country. The diesel coach he was piloting weighed several tons more than a comparable gasoline vehicle. Diesel engines are heavy. They are also, in a way that nobody on board fully appreciated, almost impossible to slow down once gravity has a hold of them. A gasoline engine, when you take your foot off the throttle, creates its own resistance. The closed throttle plate strangles the air going into the cylinders, and the engine starts acting like a vacuum pump fighting itself. That fight slows the vehicle. Truckers call it engine braking, and on a gasoline rig, it quietly does most of the work on a long descent. A diesel engine has no throttle plate. Air rushes into the cylinders freely, whether your foot is on the pedal or not. When you let off the fuel, the engine doesn't fight gravity. It coasts, it glides, and it hands the entire job of stopping a loaded heavy vehicle back to the wheel brakes alone. On Cajon Pass that afternoon, Clessie Cummins was finding out what happens when those wheel brakes can't do it alone. He kept the coach on the road. He held the gearbox in the lowest ratio he could force it into. The dying pedal kept going to the floor, and he kept pushing it anyway, because there was nothing else to push. By the time they reached the bottom of the grade, the drums were hot enough to glow, and the people on board had no idea how close they had come to dying. Clessie did. He pulled over on the shoulder, walked to the back of the bus, and stood quietly looking at the smoking wheels for a long time. He had just spent over a decade selling America on the diesel engine. He was now standing next to the proof that the diesel engine had a problem nobody had solved. There had to be, he thought, a way to use the engine itself as a brake. Not the friction at the wheels, the compression in the cylinders. If a diesel wouldn't brake itself by accident the way a gasoline engine did, then maybe a diesel could be made to brake itself on purpose. He climbed back in the cab, put the coach in gear, and finished the run. The engine he had built had carried him across America. The idea he had just had standing next to it would take another 26 years to leave his garage. And the bitterest part of the story, which Clessie himself could not have guessed standing on that shoulder, is that the company he had founded would, by the mid-1950s, push him out before his brake was ever finished. Columbus, Indiana. The spring of 1955. Clessie Cummins is sitting in a boardroom of the company he founded 36 years earlier, listening to the men around the table tell him that he is no longer welcome at it. The dominant figure on that board is a man named J. Irwin Miller. He is the grandnephew of William G. Irwin, the original banker who staked Clessie in 1919, And he has, over the course of the previous 2 decades, quietly turned the Cummins Engine Company into an industrial juggernaut, while its founder grew louder, more mechanical-minded, and harder to manage. There are arguments over engineering direction. There are arguments over corporate style. And underneath both, there is the old, unwritten question of who built the company and who is running it now. By the time the meeting ends, Clessie is out. He is 66 years old. He has been a chief engineer his entire adult life, and he no longer has an engineering staff, a test cell, a machine shop, or a payroll. What he has is the patents on most of the important diesel engines the company ever built, a comfortable settlement, and the unfinished idea he has been carrying since the day he stood beside a smoking diesel coach on a California grade. He moves his family to Sausalito, California, on the north side of the Golden Gate Bridge. He sets up a small workshop, and he goes back to work on the brake. He works on it for nearly 6 years. What he is trying to build, in mechanical terms, is something deceptively simple to describe and brutally difficult to make reliable. A diesel engine produces power because air gets compressed inside the cylinder. Fuel is injected at the top of that compression. The fuel ignites, and the resulting explosion drives the piston back down. That downward stroke is what turns the truck's wheels. Clessie's idea was to interrupt that cycle in a very specific way. At the exact moment when the piston had finished compressing the air, just before fuel would normally fire, the engine brake would open the exhaust valves for a fraction of a second. The compressed air, the air the piston had just spent enormous mechanical effort to squeeze, would escape through the exhaust pipe in a sharp bark. The piston, instead of being driven back down by an explosion, would be driven back down by nothing at all. It would then have to climb the next cylinder up and compress another full charge of air, only to release it again, and again, 6 times per revolution, hundreds of times per second. The engine, in other words, would no longer be helping the truck go forward. It would be holding the truck back, using the same mechanical force it had used moments earlier to drive the truck up the hill. That is why a diesel engine fitted with this brake makes the noise it does. Every bark is a charge of compressed air being thrown out through the exhaust before it can do any useful work. The sound truckers would later call the jakebrake bark is the sound of a diesel engine being deliberately turned against itself. The Sausalito workshop in those years was rarely quiet. Clessie's son Lyle worked alongside him on the prototypes. Together, on a series of borrowed and rebuilt Cummins NH series engines bolted to a test stand in that small bay, they wired solenoids, machined valve actuators, and ran the engines for hours under simulated load. Neighbors learned to recognize the sound of a Cummins inline 6 being throttled up against its own compression. It was not the sound of an engine working. It was the sound of an engine being held. Clessie filed the patent in 1961 under the title Engine Brake. His son Lyle is named alongside him on the filing. The application would eventually be granted as one of a small family of related patents that together formed the legal and mechanical foundation of every commercial engine brake to follow. On the test bench, the prototype held. A 6-cylinder Cummins NH series engine, producing roughly 220 horsepower underload, could absorb nearly the same amount of horsepower running as a brake. A loaded truck descending a 6% grade was, in effect, dragging its own engine up an invisible hill that exactly matched the one it was coming down. Clessie now had a working engine brake, 6 years of refinement behind it, and a patent in his name. What he did not have was a manufacturer. The Cummins Engine Company, the firm whose name was on the engines he had just modified, did not pick up the brake for production. Whatever the reasons given inside the company, the practical effect was the same. The engine that bore his name was not going to carry the brake that bore his idea. Clessie Cummins, 72 years old and deep into his second career, was going to have to find someone else. Bloomfield, Connecticut, the mid-1960s. The Jacobs Manufacturing Company has been making industrial chucks, drill chucks, and machine tool components in the Connecticut River Valley since the early 20th century. It is more than 60 years old by the time Clessie Cummins walks through its doors with a working engine brake and a patent in his name. It is not, on paper, the obvious choice to take a heavy-duty trucking invention to market. But Jacobs has the two things Clessie needs. It has serious metalworking capacity, and it has a leadership willing to bet on a product nobody else in the industry wanted to touch. The licensing agreement gets signed. Jacobs takes over manufacturing, refinement, and distribution. The product gets a model designation, a part number, and a name nobody at Jacobs intended to become a piece of American highway folklore. Officially, it is the Jacobs Engine Brake. On the road, almost from the first installation, drivers shorten that to the same two syllables they will use for the next 60 years: jakebrake. The first commercial units start going out the Bloomfield factory door in the mid-1960s. They are bolted onto Cummins NH series engines first, the same engine family Clessie had used on his test bench. From there, the brake migrates outward across the heavy truck industry through the late 1960s. Kenworth and Peterbilt are among the early adopters offering it as a factory option, and the major American heavy truck builders follow over the next several years. By the late 1960s, a long-haul rig pulling a loaded trailer over the Rockies without an engine brake is starting to look like a rig that is missing something important. And on the grades, drivers start to hear it for the first time. At any scenic pullout near the bottom of Donner Pass on Interstate 80 in California, near the western portal of the Eisenhower Tunnel on Interstate 70 in Colorado, or anywhere along Monteagle Mountain on Interstate 24 in Tennessee, the sound is the same. It is the sound that almost nothing else in heavy industry makes. It is a deep, fast, mechanical bark that comes in long bursts as a loaded 18-wheeler crests the grade and starts down. Each burst is the engine releasing compressed air through the exhaust, 6 cylinders at a time, hundreds of times a second. To a trucker, the bark is the sound of safety. It is the sound of the truck holding back against the hill instead of running away from the driver. It is the sound of cool drum brakes at the bottom of the descent instead of glowing ones. The numbers begin to bear that out almost immediately. Long-grade brake fires drop. Runaway truck ramp incidents on the famous descents drop. Insurance underwriters start asking whether a fleet has engine brakes and adjusting their premiums when the answer is yes. State trucking associations start recommending engine brakes on heavy rigs running mountain routes. By the early 1970s, a working jake brake is no longer a niche option. It is, for serious long-haul work, expected equipment. Jacobs Vehicle Systems, the division that grows up around the brake, becomes the dominant supplier in a category Clessie Cummins essentially invented from a workshop 3,000 miles away. So here is where the story should end. A retired chief engineer, ousted from his own company, spends 6 years in a workshop building a brake that would go on to save thousands of lives, license it to a manufacturer that builds it well, and sees the entire heavy trucking industry adopt it inside a decade. Clessie Cummins lived just long enough to see the early adoption. He died in 1968, 7 years after the engine brake patent was filed, and only a few years after the first Jacobs units went on real trucks. He did not live to see the jake brake become standard equipment. He did not live to see his name attached, posthumously, to one of the most important pieces of safety hardware in American trucking. He also did not live to see what happened next. Because there was something about the jake brake that the engineers at Jacobs, the truckers running it on Donner and Eisenhower, and the insurance companies underwriting the fleets had all noticed and largely shrugged off. The same mechanical event that made the brake work, the rapid release of compressed cylinder air through the exhaust, also made the brake loud. On a properly muffled rig, it was a controlled bark. On a poorly muffled rig, or on a rig with the muffler removed, it was something closer to a burst from a heavy caliber machine gun. For most of the 1960s and 1970s, that loudness was a non-issue. The trucks ran on rural interstates, descended grades through forests and farmland, and barked their way safely down to the valley floor with nobody around to complain. That was about to change. Not because the brake changed, because the country around it did. Pacific Beach, Washington. The mid-1980s. A small coastal town on the Olympic Peninsula posts one of the earliest of what will eventually become thousands of signs along American roadways. The sign is white, rectangular, and unambiguous in the way only municipal signage can be. It reads in black block letters, "No engine brakes." A trucker descending into Pacific Beach with a loaded trailer reads that sign, looks at the grade in front of him, and faces a question that nobody in Clessie Cummins' Sausalito workshop ever imagined a driver would have to answer. The brake on his rig was designed, patented, and installed for one reason. It exists so the truck does not run away from him on a hill. The sign in front of him is telling him, under threat of fine, not to use it. He has roughly 2 seconds to decide which one to listen to. To understand how the United States got from expected equipment on heavy rigs to finable offense in town after town in less than 20 years, you have to understand what was happening on the land next to the interstates during those same years. The Federal Aid Highway Act of 1956 had built the interstate highway system through what was, in most of the country, open agricultural land. For the first 10 or 15 years, the trucks ran past farms, forests, and the occasional small town. Nobody lived close enough to the right-of-way for the noise of an 18-wheeler descending a grade to matter. Then the suburbs caught up. Through the 1970s and into the 1980s, American residential development pushed out from city centers along the same interstate corridors that the trucks had been running for 2 decades. Subdivisions went in within a few hundred feet of the highway shoulder. Real estate developers marketed those lots as commuter-friendly, sometimes with a view of the road, almost always at a discount that reflected the proximity. People bought the houses, moved their families in, and discovered the thing nobody had told them at closing. The trucks were loud. The trucks had always been loud. The trucks were loud before the subdivision was a blueprint. But the families lived there now. And the engine brakes, the ones doing the actual work of slowing 80,000-pound rigs down a grade, were the loudest part. The first wave of municipal ordinances followed. Pacific Beach, Sandpoint, Idaho, Hendersonville, North Carolina, parts of Salt Lake City, and stretches of state highway in Oregon, Washington, Colorado, Tennessee, and Pennsylvania all moved to restrict engine brake use within town limits. Each ordinance written slightly differently. Some banned engine brakes within town limits entirely. Some banned them only at certain hours. Some banned only the unmuffled versions, which was the version that almost no driver could prove on the spot they were not running. Most municipal officers writing the citation could not tell, by sound alone, whether a properly muffled engine brake had even been used. The result, on the ground, was that drivers on long descents into populated areas faced a real and immediate choice. Use the brake the rig was built to use, the brake that had been keeping their wheels cool and their cabs unsmoked for 2 decades, and risk a citation that could run several $100s. Or pump the wheel brakes the whole way down, get to the bottom with hot drums, and hope the next descent was not steeper. Most drivers did the math. The fine was certain. The brake fire was probabilistic. They downshifted, rode the wheel brakes, and prayed. Some of them did not make it down. The cynical thing about the bans, the thing that almost nobody outside the industry has fully sat with, is that the noise problem was solvable without banning the brake. A properly muffled engine brake on a properly maintained truck makes a sound that is loud, but not the sharp bark that drove people to their city councils. The bark that the suburbs hated was the bark of a poorly muffled rig, or a rig with the muffler removed entirely, which was already a violation of federal noise standards in most cases. Enforcing the existing federal noise standards on each individual rig would have required municipal officers to measure decibel output at the curb on a moving truck. That is expensive. That is technical. That requires equipment most small-town police forces did not have. Banning the brake outright, on the other hand, required nothing more than a sign and a citation book. So the signs went up. By the early 2000s, no engine brakes signs lined American interstate corridors from Washington State to North Carolina. They appeared at the entrances to towns. They appeared on the descents into valleys where new subdivisions had been built. They appeared, in some cases, on grades steep enough that the runaway truck ramps a few miles farther down the road were paid for with state and federal money, while the brake that would have prevented those runaways was forbidden by the town at the top. Truckers, the people whose lives the brake had been invented to save, were left with a working safety device they were no longer allowed to use in the places they most needed it. And every year, the runaway truck ramps still got used, and every year, drivers still died on grades. Bloomfield, Connecticut. Today, the Jacobs Vehicle Systems plant in Bloomfield, Connecticut is still building engine brakes. 60 years after the first commercial jakebrake left the same factory door, the company is still the dominant supplier in a category Clessie Cummins essentially invented alone, in a workshop 3,000 miles away in the last decade of his working life. The product line has expanded. The mechanical principle has not. Every modern engine brake on every modern heavy-duty diesel-running American highways today is a direct descendant of the patent Clessie filed in 1961. Millions of units have shipped. The brake is now standard equipment on essentially every long-haul Class 8 truck built in North America. It has been adapted for Cummins engines, Detroit diesel engines, Caterpillar engines, Mack engines, and Volvo engines. It has been refined, electronically controlled, integrated with engine management computers, and made quieter on properly maintained rigs than Clessie's prototype ever was. And in hundreds of municipalities across the United States, it is still illegal to use. The signs that started going up in the 1980s are still up. New ones still get installed. city councils still pass new ordinances. Some of the original towns have updated their language to specify unmuffled engine brakes, which is the technically correct distinction Clessie Cummins would have recognized as fair. Most have not. In most places where the bans exist, the citation officer at the side of the road cannot tell, by sound alone, whether the rig coming down the grade is using a properly muffled brake or no brake at all. The driver, on the receiving end of the citation, cannot prove he was using the legal version. So most drivers descending into a posted town with a loaded trailer simply do not use the brake at all. The cost of that absence does not get tallied in any single statistic. It gets paid out one runaway truck ramp at a time, one brake fire at a time, one driver who downshifts and rides the wheel brakes the whole way down, because the alternative is a citation he cannot afford to absorb on a per-mile rate. What endures then is mostly the geography. The Bloomfield plant endures. The Sausalito workshop is long gone, but the patent that came out of it endures, in every modern variant of the brake. The bands endure. The grades endure. The drivers endure, descending those grades every day, doing the math the way drivers have done it for 40 years now, weighing a fine against a fire. And the people who live next to the highway endure too, in their houses, with their windows closed against a sound they moved within earshot of after the trucks were already running. Clessie Cummins died in 1968 in Sausalito, the same town where he built the brake. He was 79 years old. He had spent the last decade and a half of his working life on the engine brake, and the last few years of it watching, from a distance, as Jacobs began bolting the first commercial units onto Kenworths and Peterbilts on the West Coast and the Rockies. He did not see the bands. He did not have to. The grade he came down on Cajon in the early 1930s, with the brakes going soft under his foot, and the city of San Bernardino sliding into the windshield, is still there. Trucks still descend it every day. Most of them, on that particular stretch, are still legally allowed to use the brake he built. Some of the grades on the rest of the map are not. The next time you are driving through a mountain corridor anywhere in the United States, and you hear that deep, fast, mechanical bark coming off a grade above you, you are listening to the jakebrake doing exactly what Clessie Cummins built it to do. If you live near that grade and the sound bothers you, that's a fair thing to feel. The bark is loud, but it is worth remembering, on the way to the next city council meeting, that the people who live in a place vote, and the people who pass through it on their way to deliver a load do not. The brake at the top of the grade is not the problem. It is the only thing standing between a loaded 80,000-pound rig and the bottom of the hill. The man who built it spent the last decade and a half of his life making sure of that,